Hello everyone, it's Ms. Redmond here. This is lesson 5 of the chemical reactions topic and it's all about conservation of mass. If you don't have one already, please go and grab yourself a pen and a piece of paper so you can take notes and do any activities as we go through. This is your learning journey. Feel free to pause the video and write down that information. So conservation of mass is a really important idea in chemistry and in science. And the idea is that in a chemical reaction, the total mass of the reactants is always the same as the total mass of the products. So the total mass at the start of a chemical reaction or a physical change is the same as the total mass at the end. In other words, you can't create or destroy stuff. It's not magic, okay? All you're doing is rearranging the atoms in a chemical reaction or changing things between different states of matter in a physical change. So one way to think about it is if you're baking a cake, the total mass of all of the ingredients is the same as the total mass of the cake at the end. You haven't magicked the cake out of nowhere. You've put those ingredients together and you've put them in the oven to make the cake. So you've rearranged them, but you haven't magicked them from nowhere. You've done some hard work to earn that cake. Here's a more graphic way to think about it. So here you've got all of the atoms of your reactants on the left and all of your atoms of products on the right, and you can see that they exactly balance because this scale is in equilibrium. Little call back to the forces topic there. Here's another way of thinking about it. Components of the model aeroplane, you put them together and you've got an aeroplane, but you haven't created something new. You've just put together the component parts. Here's another way of looking at it. So here you've got 4 atoms of hydrogen. My mouse isn't moving. Give it a sec. 4 atoms of hydrogen. 1, 2, 3, 4. 2 atoms of oxygen. 1, 2. These are the reactants. And on the product side, you've still got 4 atoms of hydrogen. 1, 2, 3, 4, and 2 atoms of oxygen. 1, 2. So you've got the same atoms at the start and at the end. They've just been rearranged. Here's a really common demonstration that we use in science to show this. You've got copper sulfate solution in the bottom and sodium hydroxide solution here. When you drop the little test tube and those two things mix together, you get a precipitate. That just means a solid that's formed from 2 solutions of copper hydroxide, and you get sodium sulfate solution. But notice the reading on the balance hasn't changed. It's still 67.25 before and after the reaction. Here's one that's slightly different. You've got magnesium ribbon in the bottom here, sitting in some hydrochloric acid. Now this is going to produce hydrogen gas, and that gas is going to escape through the top of this flask. And so the reading on this scale is not going to be 0 grams because you're currently weighing the flask and all of the contents, but the reading on this scale is going to decrease because you're losing the gas. But it hasn't disappeared out of existence, so you haven't destroyed anything. You've just lost it to the atmosphere. So still, mass is being conserved. All right, this is a little reminder about word equations. So you've got the reactants on the left, the arrow showing they're being changed into something new, and then the products on the right. Symbol equations. Now, this is another thing that's going to come up again and again throughout chemistry because it's so useful to understand. But don't panic if you're not getting it right now. It's only year 7. We're going to revisit it time and time again. Okay, so we've used word equations to represent chemical reactions. For example, iron oxide plus aluminium, arrow, aluminium oxide plus iron. We can also write chemical equations using the formulae of the substances involved. So here is the symbol equation for that reaction. We've got Fe2O3. That's the formula for iron oxide. Plus 2Al. Al is the symbol for the element aluminium. Then we've got an arrow to show that those things are being rearranged. And we've got Al2O3. That's the formula for aluminium oxide. Plus 2Fe. Fe is the symbol for the element iron. So this equation is giving you exactly the same information as the word equation, because it's showing you that iron oxide and aluminium are reacting together to produce aluminium oxide and iron, but it's also showing you how much of each reactant and product there is relative to each other and how much of each atom. So the purple number here and here is showing you that you've got 2 atoms of aluminium and 2 atoms of iron. And the pink numbers down here are showing you how many atoms within that compound. So that's showing you there's 2 atoms of iron and 3 atoms of oxygen. And over on this side, you've got 2 atoms of aluminium and 3 atoms of oxygen. Here are some examples of word and symbol equations just for you to get familiar with them. So carbon plus oxygen, arrow carbon dioxide, C plus O2, arrow CO2. You can see that those two things have combined to make this thing. Iron plus oxygen, arrow iron oxide, 4Fe plus 3O2, arrow 2Fe2O3. So this is showing you've got 4 atoms of iron, 3 molecules of oxygen, and then 2 molecules of iron oxide. Copper carbonate, arrow copper oxide plus carbon dioxide. CaCO3, arrow CaO plus CO2. You'll notice that these are all reactions that we have talked about or used in this topic. Top one's burning, second one is oxidation, and this one is thermal decomposition. What else have we got? Methane plus oxygen, arrow carbon dioxide plus water, so this is burning again, or combustion. CH4 plus 2O2, arrow CO2 plus 2H2O. And then we've got hydrochloric acid plus calcium carbonate, arrow calcium chloride plus carbon dioxide plus water. And the symbol equation 2HCl plus COCO3, just one of those because there's no numbers next to it. Arrow CaCl2 plus CO2 plus H2O. So I've really rattled through those. So feel free to pause this bit of the video and write down this information if you'd like to. So this reaction is the only one that we haven't talked about in this topic, but this is going to come up in the acids and alkalis topic. Summary slide. Conservation of mass. The total mass of the reactants in a chemical reaction is the same as the total mass of the products. The total mass at the start of a physical change is the same as the total mass at the end. Balanced symbol equations. We can write chemical equations using the formulae of the substances involved. Balanced symbol equations show how the atoms are rearranged in a chemical reaction. Balanced symbol equations also show how much of each reactant and product there is relative to each other. Thank you very much for listening, and I'll speak to you next time.